Covalent bonds are a type of chemical bond where electrons are shared amongst nuclei. So this is an example of hydrogen. Hydrogen has a single electron, and in order for it to achieve a noble gas configuration, it needs to gain an electron. So let me just talk generally about electrons and energy. A lot of times, elements or molecules won't be able to strip away electrons because they don't have a high enough demand for electrons to gain an octet, something like that happens in ionic bonds. In ionic bonds, an element like fluorine takes away an electron from something else that gives them up easily in order to gain an octet. In something like this, sometimes I get the situation where it's really an element cannot easily give up an electron, like hydrogen, for example. Well, hydrogen can give up electrons if something is able to take away the electron, but often it won't be able to accept an electron easily enough to just take on a whole electron because it will be energetically unfavorable because of the amount of positive charge it has to negative charge, or it would be in a higher energy level, or it won't easily be able to give up an electron as well. So in order to, I guess, just think of it this way. If someone was hungry and they wanted to order a pizza, but they didn't want to order a small pizza because it was too little, but at the same time they didn't want to order a large pizza because it was too much, what's the next best thing to do? Well, it would be to get one of your friends and then share a pizza. So basically, covalent bonding is just like ordering a pizza and sharing it. So these hydrogen atoms, they have attraction for the other. Let's say I have two hydrogen atoms. This hydrogen atom is going to be attracted to this other hydrogen atom's electrons. The nucleus of this atom will be attracted to these electrons. And same goes for the other one. So they will begin to come together due to the positive and negative attraction, and they'll end up sharing the electrons. Now there is a distance where it reaches an equilibrium between the repulsion between both nuclei and the attraction for the electrons. So this is what this diagram sums up. These hydrogen atoms are attracted to each other's electrons. So they begin to pull each other together, and it gets to a point where there is an idealized distance between the repulsion of the nuclei and then the attraction from the nuclei to the electrons. And that distance between the nuclei is called the bond length. If I start getting closer, the distance between the two nuclei, which is what this is, probably should have said that first, and this is energy. So as these two things come together, the energy starts decreasing because these hydrogen atoms will now have a noble gas configuration, but at the same time, they won't have additional negative charge by accepting an entire electron. So they are able to achieve a more stable energy state. They are in a lower energy state. That's what this diagram shows. But if I cross that threshold and the nuclei start getting closer and closer together, then the energy starts going up, and then it goes up exponentially. That's why it requires a lot of energy for fusion, because look how quickly it goes up. As these nuclei come closer and closer together, basically that's what's happening. These elements get so close that they end up fusing together. That's what nuclear fusion would be if I kept going this way. So it would take a lot of energy to overcome those forces of the nuclei repelling. It's very, very hard to do. It can only be done in nuclear reactors and in stars, basically. It takes a lot of pressure and heat. But that's the basic idea of covalent bonds. Atoms, elements, molecules sharing electrons. Now in this case, I have two hydrogen atoms sharing electrons, so they're going to share them evenly. Each one of these atoms has the same amount of pull. But later on, what I'm going to learn about is that there are different types of covalent bonds. One of those being polar covalent bonds. Something like this. Now, fluorine has a higher demand for these electrons, so it will be able to pull harder on the electron. So the electron, they might share an electron, but it will spend more time over by fluorine than it will by the hydrogen. So that's what's called a polar covalent bond, because one of the ends is more negative and the other one is more positive. Because fluorine has a greater power to pull those electrons than hydrogen, it will spend more time over there. And there are also other types of bonds as well, which are not really so important right now. There are double bonds, triple bonds, so something like this. An oxygen double bonded to a carbon. And there are triple bonds as well. Nitrogen, I think there are even, I know there are quadruple bonds for sure, with transition metals, and I think there's 5 as well. I don't think of 6 there is. Maybe. Could be possible. Probably not very common. But yeah, these are different kinds of bonds that can exist. It's just electrons being shared as opposed to one taking the whole thing. Because most of the time, it's going to be not in their best interest to take the whole thing, unless it's a very, very unless it has very high electron affinity. I guess that's the best way to put it.